Like all good videos, this one starts with a disclaimer. This series of videos is mainly focused on Intel Realsense camera use for FTC. Some of the information presented could be useful for someone else, but just keep in mind this tutorial is oriented towards first tech challenge use. I cannot guarantee that this will work in any other circumstance. Another disclaimer. I am not a professional. I have only been programming for around 1 year, and I am mostly self-taught. Keep this in mind if you find my code to be sloppy or ineffective, as I am still learning about Java. Alright, disclaimer over, let's get on to the rest of the video. Alright, so here's what you're going to need for this tutorial. You're going to need an Android phone, a computer powerful enough to run Android Studio, an Intel Realsense camera. This tutorial is meant for the T265 for its tracking capabilities, but you could also use this tutorial for another Intel Realsense camera. And finally, you're going to need a version of Android Studio, preferably 3.5.3 since that's what I use, but it might work on versions above that. This project is pretty light on engineering work. The main thing is that if you want, you can download this design for a stand in the description below and 3D print it. Alright, now so we're going to attach the Realsense camera to the mount. You're going to line up the holes on the mount like so, and you're going to take your screwdriver and you're going to screw it in. Finger tight, no need to use power tools here, you don't want to damage the camera. And just to note, the screws I'm using here are M3 by 18 millimeters long. You might be able to get away with 15 millimeters if you have those, but I'm using 18 millimeters just to be safe. And we're just about done here, and we're done. Alright, so now we just need to place this into the robot, and you tighten those screws and it's mounted. So here we're moving around the camera, and if you look at the screen on my laptop, you're going to notice the 3D position is being updated constantly. So if you look at the screen, you'll notice that we are getting the 3D position of the camera live, which is very useful if we want to track a robot's position around the field. So how we're going to use this is we're going to take the C++ code from the camera, and we're going to use NDK and the JNI to send over that data over to our Java code. Alright, so here we are in the Intel Realsense SDK, and as you can see, as the camera moves, it's showing it and drawing a line, which is a much better representation of what that 3D positional data is. First, we must understand how do we communicate with Intel Realsense using our Java. As I explained previously, the Intel Realsense cameras use C or C++ to obtain their positional data, while in FTC we use Java mainly to obtain or to control a robot. So for this, we're going to have to use what's called the NDK, or the Native Development Kit in Android Studio. So the NDK serves to give us the data from C++ and convert it into Java, which we can use as in our variables to use in our coordinate system. So the first thing you need to do is obviously you're going to install the NDK, which can be done via the SDK manager. But the NDK includes something called JNI. So NDK has like your build tools for C++ and all that. But what you really need to convert that C++ code into Java is Java native interface. Java native interface is like a translator. You're going to have functions in each of your programs that pretty much have like their own syntax, which tell the code that you must go to this file and you're going to run this function. Um, so we can use this to get a variable, get a string, or in our case, we would get positional data in the form of like a double or an integer, um, which we can then use to interpret our position in Java. Um, one thing that we need to make sure is that a lot of programs in C++ need to use um, external libraries, which you would include using the include function in C++. To make sure that we can properly include these, we need to use CMake, which I mean is used by any C++ code. Well, not any, but most C++ code. But this is, you can download this also via the SDK manager. And this one is going to get our LibRealSense package from Intel, which I will show very soon how you're going to install and set that up. This pretty much includes all of the information we need for connecting to our cameras and obtaining the code. This library is found on GitHub. If you search LibRealSense, you'll find all of your wrappers. And on there is an Android version, but it's mainly meant for the depth camera, the D435. And if you're working with that, that Java is going to be good for most things, but if you want to do something advanced or you want to use a different camera, you're going to have to use the NDK and the C++ code. Now, understanding a little bit of C++ code is necessary because you need to know a little bit what you're doing. But I am no expert in C++, and it's still possible. You just need to be able to understand what does what. You can obviously Google stuff. Google is a very helpful resource during this. So using this information, we can start to piece together our puzzles. So now our JNI has to communicate with our C++ code, which is also communicating with our LibRealSense repository. And then our JNI code is also communicating with our Java code. Now, our Java is running our robot, as mentioned, and our C++ is running our camera. So what we're going to use is a JNI function to get it to return a string or variable, in our case, that we can then interpret in our program. And that will lead to our coordinate system. And that's about it. I hope you enjoyed this little rudimentary explanation. And next, I'm going to be getting into the actual installation of this LibRealSense package in Android Studio. It is a bit it takes a little bit. It's very outdated in the LibRealSense example, the native example they have in LibRealSense. It's very outdated, so you're going to need to move some files around. You're going to need to add some stuff. But overall, it's very doable, so just follow along and you'll be right on your way to programming these Intel cameras using Java code. Alright, so here's how we're going to create our Intel Realsense project. So the first thing you're going to want to do is you're going to want to make sure you go to Configure and go to SDK Manager. Go to SDK Tools and make sure you have NDK and CMake installed. That's very important for this project. Next, you're going to start a new project, and we're going to go to native C++. We're going to name it something like Intel Realsense Native Demonstration. You can name it whatever you want, really. It's not really important. And then next, so now we need to change this toolchain default to C++ 14. This is what I found worked best. So now we're just going to wait here and let it build. It shouldn't take too long. If you get an error, I always recommend Googling. Now that that's synced, let everything open, and now we're gonna make sure that we include our NDK firstly. So you're gonna go to Gradle Scripts and go to local.properties, and now open up your File Explorer, and you're gonna find your SDK location, find the NDK, and open that folder with like a bunch of numbers. That's your version. Copy that directory, and now you're going to go in here, you're going to type ndk-dir equals, then you're going to paste it in. Now you're going to change these uh, colons and slashes to fit what is above. You just have to add two slashes in some places, and you need to change like the little C thing. So now we've included our ndk directory. Um, Now we're going to close Gradle scripts, and we're going to change the location of our CMake file. So you're going to go to app, source, main, CPP, and your CMake list.txt. You're going to move that into your app folder. Okay, and then now you're going to open it, since you won't be able to open it back up in the Android view. Switch back to Android, and now we're going to open our build.gradle, but the module app one. Here we're going to remove the stuff before the CMake list.txt, and we're going to head over to the Realsense, the native example. This will be linked below. You're going to open up the build.gradle file. Oops. Your build.gradle file. And you're going to copy everything below this comment. That you're going to copy all that. Open up Android Studio. And you're going to scroll down to the bottom. Underneath dependencies, you're going to paste that all in. You're going to change this version to 2.3.34.0, since that was the version up to the newest version at the time. You're going to change that to say includes. Just follow along here. Sorry, I'm going a bit too fast, but open your CMake, the CMake list.txt from the example. We're going to copy all of this stuff right here underneath the Realsense dependencies. Open up your CMake list.txt and paste this in. And down here, you're going to add Realsense 2, no caps. This is going to help include our file. We're going to open up our Android manifest, and we're going to head over to the example. We're going to copy all of this, and we're just going to paste it in right underneath package. Now you can click sync. And just let it sync. You'll notice these little things, but they'll clear up. So now that we're done with that, we need to wait a little bit, because we have our includes folder, but we don't have, it hasn't gotten all of our stuff yet. If we go into projects and go to build, we notice there's no JNI folder. So we can open up our C++ program. And if you get this error right here, ignore that. It's just about those, like, the error identifying, like in Java, like when you get an error, it shows red. It's stuff like that. We just need to wait for this. This can take a little bit long. I usually like to wait a minute. If it doesn't work, then just go to File and close project and open it back up again. Now we notice that we have includes.librealsense 2 right here, but we notice it's not in our includes folder yet. So we're going to head over to our CMake list.txt, or sorry, our app, and you're going to get rid of that S we added. I found that if you don't add the S at the beginning, it doesn't seem to work, but I'm not an expert, so this is just what I found works the best. Just let it configure the build, and close it, and then go to File, and then you're going to click Close Project. Open back up the project, let it sync. Okay, we have our second folder, our includes. You notice the difference there, and then look, we have our little folder in our includes thing. We go to our program, hashtag include, and you use the one with parentheses, and type Realsense 2, and then now we can go to rs.hpp, and it's included. So I'm just going to type some stuff to make sure it's working, but this is how you would include it into your project. I had a bit of an issue before, but this will pretty much get you started. In future tutorials, I will show you how to actually program these cameras using the C++ language and Java. But yeah, this is the end of the project setup tutorial, so thank you. All right, now for the final part of this episode. So, due to unforeseen time constraints, I've decided to make this into a multi-part series. And while I'm at it, I'm just going to add some more parts. So, there's going to be 4 parts, including this one. The first one is obviously setting up your project to run with Intel Realsense. The next one will be my what I call the pseudo odometry. It uses a bit of math to work as a coordinate system without having to use odometers. The next one will probably be odometry with actual odometers, since our team has gotten those recently. And finally, the final addition will be using the tracking camera as part of your coordinate system. I'm going to be working on these videos over the next few months, and um, and then I'll put them together in our playlist so you guys can take a look at them and you can choose which ones you want to look at. So there's going to be essentially 3 different ways to use a coordinate system, um, starting kind of from the more basic to advanced coordinate systems, each with differing level of results. Um, but overall, this has been the first part, and thank you all for watching. Tune in next time for when I show you how my pseudo odometry works, because we didn't have odometers at the time of making it, but I think it works pretty well by just relying on math and the encoders built into the motors.